Good afternoon for the last time today. Mike Warlick from AFCEA International, and I'm glad that some of you are hanging around. Some of you are hanging around for other reasons, maybe. I hope you're going to stay for the presentation. This afternoon, we've got Colonel McCloud, who will be our speaker. And I won't go through questions because you know the routine. Most of you have been here. Use the mic, or you can state with a command voice from where you sit. Colonel McCloud, United States Air Force, is the director and commander of the Joint Spectrum Center, Defense Information Systems Agency. He's responsible for providing direct support to the Joint Chiefs of Staff, combatant commands, and military departments' effective and efficient use and application of the electromagnetic spectrum, and control the electromagnetic environment effects it generates in support of national security and military objectives. He's going to provide us today with an overview of the electromagnetic spectrum. He changed his title a little bit here, so I'm not exactly sure I'm right on track. But he's going to talk about the importance to the spectrum, to our coalition, and within the operational environment. Please join me in welcoming Colonel McCloud to the stage.
Okay, well, good afternoon. This is a very unenviable position to be in because I think in about 15 minutes, happy hour is starting some other place, so I'll try to go through this pretty quickly. This is going to be less of a brief than it is a discussion, because when you talk about the electromagnetic spectrum, that brings up a lot of different views in people's minds. So let's get this started. So this is where I work. This is who I have to answer to. This is, as you can see, there's multiple different organizations that we have to work with. We talked a little bit about some of the different things. It's spectrum and policy from the DoD CIO standpoint, the Joint Chiefs of Staff, the combatant commands, U.S. STRATCOM as the actually operational sponsor for a lot of the things that we do, and where I sit as the Joint Spectrum Center's Director Commanding Officer. So I want to introduce you to Jack. Now, Jack, as the name implies, is a jack of all trades and master of none. Sometimes I'm Jack, sometimes you're Jack, and sometimes we don't know Jack when it comes to the electromagnetic spectrum. But you know what? Jack is a perfect example of who we want to be from a coalition environment. Jack is, ambidextrous. Jack is multilingual. You find Jack in a lot of different briefs. Jack is very knowledgeable about a lot of different things, and he can work with a lot of different people. We want to be like Jack. Now, Jack, like most of us, have different perspectives, how we view things and how we think about things, and there's a myriad of different possibilities when we come to it. If you were here for the panel earlier, when I used, EMS, people were thinking one thing. When I was talking to Joe Carson, when he mentioned NIST directive, it's like, okay, you're talking NIST, like, FIPS 40. No, he was talking a whole totally different things, and that matters. It matters that we have an understanding of what we're talking about, what we're referencing, and with that said, I want to make sure that you have a good reference when I talk about the electromagnetic spectrum. So let's start with this. What is it? The electromagnetic spectrum. I'm not going to read it to you, but it's pretty clear cut right there. And you use it daily. Daily you use it. You probably don't have an understanding of everything that you're using, but you use it daily. I'll give you an example, and it shows it right there. Your microwave operates at 2.5 gigahertz. You ever wonder why sometimes you can't get a great connection in your household? Well, it's because your microwave, or maybe your stove, maybe something else is interfering with. 5G is probably better, but you have to be a little bit closer. The Internet of Things is coming. 5G is the next thing that the people are going at. Everybody is emanating something from an electromagnetic spectrum standpoint. If I was to do it, and I haven't, and I will not, because it has legal implications, I can tell where each one of you are pinging at right now. If I was to put this in some type of application, each one of you will be radiating a certain EMS footprint. But the fact of the matter is, we really don't have an understanding of that. You know, everyone thinks about EMS in a different way. If I was to ask anyone out there, hey, what is your digital footprint? You can come up with it pretty quickly. You can probably hit a few things, but no one can define what their EMS footprint looks like. Now, as a warfighter, that matters to me. That matters to me. When I think I am stealthy, am I? I may not know what's inside that black box, but because everything is radiating, I can see that black box move. There's things that I can do to stop that. It's hugely important that we have an understanding of that. So you see here, you have 7 different basic types of EMS, right? Everyone has applicability in what we do. So when we talk about cybersecurity and things of that nature, if you do not have that aspect in your mind, are you creating a risk, an unnecessary risk as we move forward? Yeah, all depends. So let's go on. So lexicon matters. All right. Everyone recognizes that as a pepperoni pizza. That's a pepperoni pizza. So I'm going to tell you a military story, all right? And I'm going to give you the obligatory preamble to that. There I was. I'm in Stuttgart, Germany, loving life. You know, I got a place that's off the economy, and I'm living in Göttingen. You know, and I'm feeling pretty good. I think I'm speaking the language. So I'm a foodie, and like all foodies, I want to find something to eat in the local economy. So I'm going around looking. I'm like, hey, I'm going to start off easy. I'm going to go someplace and order me a pizza. So I see this establishment, and I go inside there, and I say, Guten Abend. Zwei Pepperoni Pizza, bitte. Guy looks at me. Okay, starts doing his business, and he's doing it, right? I'm feeling confident. I'm in the economy, I'm speaking the language, I've done good. So I'm all excited that I've done a great job, and so I bring back the pizza without looking at it, and I take it home to my wanting family, my wife and daughter who are there, and they're hungry, and I open up the box and say, look what I've done for you. And they started laughing. I was like, what's going on? I turn around and look at the box, and my pepperoni pizza is actually a pizza that's covered in peppers. Covered in peppers. And why is that? Because in Deutsch, peppers are peppers. Roni sounds like Oni, O-H-N-E, which means peppers only. Lexicon matters. All right, so what do you think of this right here? So we have the International Telecommunication Union, and it's divided into 3 different zones. And each one of those regions there, they have a different perspective on their electromagnetic spectrum. It's a finite, or so we think, it's a finite realm in which everyone has a different slice, hence the pizza, of how they approach it, what they're going to do with it, and how it's going to help design or build up their economy. So when we talk about coalition or mission partners, we have to have an understanding that, we don't go into any war or any conflict alone. We have to make sure that we have an understanding of how it's being used and why it's being used that way, and how we can actually couple or federate, however you want to view that. It's hugely important. Yet, from an industry standard, I would expect, or rather than I would expect, you would expect that just like when you take your laptop and you bring it into another country, well, your power supply sometimes switches from 120 to 220, 240 and things of that nature, where you might have to put an adapter on it. Yet, how many of the hardware platforms do we have out there have that same flexibility to switch to a different spectrum? It's probably hard-pressed to find one. Probably is out there. There was the Joint Tactical Radio Suite, but that was successful, not. So we have great intentions, but again, how one interprets this and how one goes about putting that into a standard, which we'll talk about later, matters. All right, so policies, procedures, and international standards and agreement. There is a bunch of them. There's absolutely a bunch of them. United Nations, I just talked about the International Telecommunication Union. We had a bunch of folks that were at the Sharm el-Sheikh in Egypt, at the World Radio Conference. And again, we talk about intentions and who wants to see what, or who wants to know what type of frequencies we're trying to look at. Sometimes we can't speak for ourselves. We have to talk to our allies to speak for us. But you look at all these different handshakes that go on inside of the U.S. alone. Okay, we have the federal side, we have the commercial side, and look at all these different people we have to go through in order to make that work. The organization that I'm part of, the Defense Spectrum Organization, has to have its hands in each one of those pots to ensure that, again, we're speaking the same language amongst ourselves before we even go out and talk to other nations out there. This right here. Right now it's showing you the electromagnetic spectrum, the operational view on level 1, and look at those different platforms that we have to deal with day in and day out. Each one of those platforms have to be protected, and when you talk about, whoa, here we go. Going through the spectrum, every domain goes through the electromagnetic spectrum. So if you're not considering that and how you go out and purchase, how you go out and supply, how you transverse that, you open yourself up to a potential vulnerability. I said earlier in one of the sessions that data is the new currency. EMS, for sure, is its broker. Because there's certain things that we can do within this electromagnetic spectrum that, even though you have the greatest of cybersecurity and things of that nature, there are certain electromagnetic effects that I can apply, that can be applied, that can disrupt that process. It's really amazing to the degree that it can disrupt it. So, although I'm showing the military platforms here, there's commercial platforms just as equal in this same environment. So when we talk about cooperating and working with not only our coalition partners, but the commercial industry, it's hugely important that we have an understanding that the standards that they use don't do anything that adversely affect how we go out and prosecute the missions. It's all about that EMS superiority and enabling the electromagnetic spectrum to do the things that we need to do in an operational environment. And that is equally important in a commercial environment. You know, I know a lot of you in here know, that, well, maybe you don't, that we sell off a lot of our spectrum. And that's a good thing. It's not a bad thing, because I give you this analogy. You know, spectrum is sort of like the food, and like we talked about that, you know, if you've ever known anybody or ever seen a movie, and I won't say if you've known anyone, don't raise your hand on that, you know, was a convict, and you know, while they're in jail, they eat their food like this, right? They're covering it. Well, that's how we did it back 50 years ago or so when we talked about the spectrum. We gave a huge chunk to the military, and the military, to this day, couldn't tell you how much they actually used of that spectrum. That's a waste of a resource. So we have a presidential directive that says, thou shalt share the spectrum. So we're moving here and we're moving there, and we're trying to get more efficient and effective with that. That's because the commercial industry understands the importance of that spectrum as a viable source of economics. So we have to be able to look at that and figure out how do we go about sharing that spectrum and using it in a more efficient and effective way, all while trying to maintain the EMS superiority. World events. It happens far too often. And when you look at this right here, you know, it's sort of like a denial of a service, because everybody wants to come out there and do great things and support whatever's going on, but what inevitably happens is we get a denial of service. You know, every nation is requesting assistance, but, you know, because we don't have command and control, or we cannot efficiently and effectively distribute, assign spectrum so that you can communicate with each other, we end up taking weeks to really get at being able to do anything for that respective country. This is the spectrum. This is our, I mean, just by comparison, this is United States and a representation of UK. Now, I put it side by side to show you that, you know, they're dealing with the same, you know, frequency bands, but look how they're sliced up. Totally different perspective. So when we go to a country, you know, whether that be in an exercise or anything of that nature, and we go over and we say we need this amount of spectrum, what we get sometimes is slices. And because it's in slices, the efficiency and effectiveness of the operation sometimes suffer. We have to be able to combat that. We need industry to look at how do we go about taking this information and making it flexible like you would your PC. I don't need to know, exactly what part of the spectrum you're giving me per se. What I need to know is whatever you are giving me that I can couple it and do it efficiently and effectively. And now part of that is going to be software, part of that's going to be hardware. So as you look at that, it's hugely important. There are environmental effects that happen naturally. When I look at these light bulbs here, because I'm now in this business, I understand that these light bulbs are also emitting a frequency. So it's hugely important that if you were to put a light bulb, say, in an aircraft, okay, what is the effect of that light bulb internal to the aircraft, and what is the effect of that light bulb as you cross, different country lines? It has to be something that's considered. All right, now, given all that, how do you visualize that? So this right here is, representation of, a heat map and different aspects that occur with that. And I believe this thing is really working well for me today. So visualization, how do we visualize that? It's hugely important. And in this day and age where you got a new generation that will rather take their cell phone and use that for a lot of different applications, we're not designing things that way. And the ability to visualize the electromagnetic spectrum is much easier than actually explaining it, especially to a newer generation. Yes, it might be electrical engineers and things of that nature, but the fact of the matter is it is much easier to visualize the electromagnetic spectrum than it is to talk about it. So how do we get that strategic messaging across? Here are some of the inherent EMS environmental effects. This is a Faraday cage. Everyone knows what a Faraday cage is? Don't want to insult anybody. Well, I tell you, a Faraday cage is only good as everything that's inside that Faraday cage. Because if there is one pair that is unshielded, it's kicking out a low emission of frequency. And if I can detect that low emission of frequency, I can do pretty much anything I want inside that cage. Don't you think it might be something appropriate that, say you're in your house and when you clicked on your Wi-Fi, and not only do you see yourself, you see maybe your neighbors to the next door to you and some other folks. I can deal with it here and probably see a lot of different independent Wi-Fi emissions. But if you were to use something as simple as painting your house that has a Faraday effect to it, you could eliminate that. But not a lot of people think about that. It's those simple things of that, an application of how environmental effects and the ways in which you can manage around that makes a huge difference when you're talking about in a theater of less than conflict or a conflict of war. Because we do have near-peer competitors who are very good at this stuff. Very good at this stuff. The incident where in Ukraine, you'll look it up, I'm not going to go into it, but we had a noisy neighbor in Europe that did some pretty interesting things to Ukraine using electromagnetic effects. Cyber was in there too. You can't get away from that. But again, the medium. If I could deny you access, I can do a lot of different things to you. As a cyber guy, I'm a pretty good hacker. Not better than some, better than others. But I can actually go online and figure out how to go and buy a drone, apply some basic physics, soldering and things of that nature. I don't need to take out all of DISA. I just need to take out a portion of it for a portion of a time and do what I need to do. It has huge implications. Munitions. Okay, do you think electromagnetic effects is important to the munitions? Absolutely. So there I was again, as an enlisted guy, and we're bringing out these bomb dummy units to the aircraft, and typically, like a good pilot, the pilot is out there checking the wings and checking everything, and one of those BDUs fell. As I knew it wasn't going to discharge or anything, but when I looked back, this guy was hustling, right? So guess what his nickname was? Quicksilver. So in the medical field, there are a lot of systems that they have spectrum dependencies on it. We call them spectrum dependent systems. And as we get more and more into the Internet of Things, everything is going to have an ability, everything is going to ping. Everything is going to have some type of spectrum dependency on it. And if everything has some type of spectrum dependency on it, we have to make sure that we apply good logic and good, I guess, what's the word I want to use? Applying that good logic, and we want to make sure that the environmental effects that they can produce is not going to be something that's going to be an interference to ourselves, because there's a lot of blue on blue at times. How do you look to yourself? How do you look to others? And who's looking at you? And how do you minimize that, or how do you flex it such that you emanate something else versus emanating something that we don't want the enemy to figure out? Aircraft, do we need to turn off our cell phones on aircraft? Or do we? I don't know. I'm always looking for that one person that accidentally forgets to turn off their cell phone. And I'm like, okay, should I say anything? Playing, I don't know. But you know what happens? That's because we don't understand it. We don't understand the implications of it. Definitely, if you've ever been on a cruise, how good is that connection at times? Right? Well, they're using that. There is capabilities within, again, I go back to these light bulbs, that I can actually use this as a medium of communication. So there is an inherent need to understand how to apply those RF principles. There's a need to understand all the different mediums and how you can take advantage of that. And we are not really thinking about that, because we're thinking way up here. But again, what is that smallest link? What is that weakest link, to use that word loosely, that you must address? You have to think about the electromagnetic spectrum and how it applies in every aspect of what we do. All right, so problem set. So think of that blue circle there as a collaborative mission partner coalition environment. Congested, contested, constraint, densely populated. Everything, again, the Internet of Things, everyone's pinging. There's some emission that's going on. And here's, part of the issue. We have a military economies of scale and multinational and national economics. The spectrum is a huge business to a lot of commercial entities out there. One of the things that my shop does is that for any telco to get on any military base, they have to go through my office in order to do the analysis on that, to make sure that they're not introducing any inherent hazards that's going to cause anything to go boom that we don't want to go boom. When you talk about the advent of a great competition, there are areas in theater that some of those near-term competitors are 5 clicks away. So if you're in a operational environment and you have a near-peer competitor 5 clicks away, wouldn't you want to know what you look like to them? Wouldn't you want to know what you're emanating? Conflicts other than war. The access to the electromagnetic spectrum, every domain has to go through it. Can't get away from it. Can't get away from it. Yet we're not really thinking about that, because we assume it to be always available and present like we do air. Imagine waking up and not being able to breathe. So on the other side of the house, we got, again, I talked about the 5G and the advent of the Internet of Things, and we talk about the cybersecurity and the level of permissiveness. 50 years ago, we probably were, decent at it, but, hey, the wall fell down, the Russian bear went some other place, and we're like, okay, let me think about some other things. We have atrophied in this business, okay? And then about 10 or 20 years ago, because again, we talked about the congested, contested, constraint environment, that permissive environment is not so permissive anymore. We have a directive from our commander-in-chief. The National Defense Strategy is talking about we need to share more. We need to share. We need to get closer. How do you deconflict that? How do you go about establishing the standards in such a way that you can actually do this business without causing hurt, harm, and danger to yourself or the missions that you have? All right, so here's a part of it, right? You heard about a lot of it. There's a roadmap. How do you go about doing that? Well, technology. You got to do some prototypes. You got to go out there and we need support from industry to come up with some type of ways in which we can do this. Because I can tell you right now, when we do Tier 1 exercises, we don't always get the opportunity to test out some of these things from an electromagnetic spectrum standpoint because people are fearful that things will be broken. Well, yeah, they will get broke if you don't know how to handle it. But you can't test that, on a tabletop. You have to put yourself in an environment where you can actually go through and actually break things and learn things and, reattack it. Architecture matters. You have to have an architecture out there. I'd like to say that, you heard probably earlier that in 20, there's going to be the Cybersecurity Capability Maturity Model. That says it's going to give all these different, qualifications or where you need to be at in order for you to be a part of the DoD and how it goes about doing things. It has on there what I would like to call a sweet spot. At minimum, there's probably like level 2. If you're at level 2, we can start having a conversation. And what I'm proposing is that, you'll see it later, that we need to actually develop as we go on, because you look at all these different high-level architectures and business rules and applications that are out there. It's almost ubiquitous. We have to, look at this, access controls. We have the commercial environment and what they're bringing. We have to make sure that the commercial entities who are going pretty fast are not going so fast that they leave, quite frankly, the military behind, because we're a little bit slow in terms of on the acquisition side of the house. So part of my job also is to make sure that we go to each one of these different meetings with the commercial entities and make sure that they stay in compliance with MIL Standard 464 and a few other things here so that we can still work with our commercial entities. And again, I call back to the fact that, how do you visualize that? And how do you come up with a system that allows you to work with the international partners who may be our friends today and may not be our friends tomorrow? It becomes a very complex problem set. So we'll go back to this. How do we get there from there? Part of that is going to be, we need to understand from an electromagnetic standpoint, what is that data and how do we fuse it together? There is only one DoD authorized Joint Spectrum Data Repository, and that happens to be under my purview. It's called the Joint Spectrum Data Repository. So when I talked about that data is the new currency and EMS is its broker, well, the JSDR is the broker for all joint data Joint Spectrum Data Repository. So if it has a spectrum dependency on it, if it's a part of a spectrum dependent system, it has to be put into this particular database. And we don't hold it or own it, but we are the broker. So you'll have individuals from entities from Intel, commercial, that uses this data. And I'll look back more on that. You also have to think about, again, whether you want to call it augmented intelligence, artificial intelligence, the analytics that are required to make sure that he or she who gets the data fastest and that can make that decision is going to win. We're in a day and age where you have to be able to process that in such a way and share it in such a way that the data is, people like to say, near real time. You know what? If you can help advance the football a little bit quicker than the next person, guess what? You're winning. And that's what we're trying to do. Situation awareness. Again, you have to have an understanding. How do you look to yourself? How do you look to others? And how do you master that from an EMS standpoint? It is one of those areas that is critical, yet we don't really think about it because folks don't have a real good understanding of the spectrum other than the fact of, okay, there's electronic warfare. Okay, we're still doing that business where we have to make sure that our systems aren't being jammed, and if they are, how do we go about attacking that using the different disciplines in there? That is always a part of it, but the umbrella in which electronic warfare falls under is the electromagnetic spectrum. Allocations and assignment. Again, we have to be a little bit more efficient on how we use the electromagnetic spectrum. It's the day of assigning 4,000 frequencies to one particular system or one particular, those days are gone. We can't do it any longer. We have to be more efficient and more effective at that. And so you have to come up with a way in which you can easily share that, and part of that is going to be machine learning, part of that is going to be better algorithms to help, help in that decision-making process. And then we come to, the crux of it all. What is the electromagnetic standards, the interfaces and architectures that are required to help move us to the next level? And I will propose to you that it looks like this as we move forward. You bring all those different things that I talked about. You talk about the ability to be flexible. You talk about the ability to have an adaptability to the different regulatory things that go through, meaning the U.S., meaning whatever mission partner you're working with. You have to be adaptable, you have to be flexible, and you have to have agility to move quicker. Some of that can't be done, but you know what? We have to move towards that. And again, you start where you are, use what you have, and you get to where you need to be. So let's translate that a little bit more then. So EMS standards and architecture consensus. Again, that blue spot is that, sweet spot, that middle ground for the mission partners, coalition partners. We talk about EMS standards, interfaces, and architecture to give you the ability to command, give you the ability to collaborate, and give you the capacity and capability to get you right here. An EMS enterprise architecture, a capability maturity model. And based off that model, you can look at that standard and understand, okay, this is where I fit as this applies, and what do I need to do to help me get there so that I can, be part of that puzzle, be part of that federation, be a part of that coupling and uncoupling. And how do you do that? Well, we have to come up with those standards, right? And that allows you to plug in. And when I say plug in, here's where we go. We have to define a common set of capabilities and activities and services, right? We have to, what are those objectives? The objectives are to have interoperability, and we want to have the flexibility and agility to move in almost any community. It has to be informative. We have to gather the requirements. And again, when you talk about requirements, you have to be very careful that you don't define users' requirements, because sometimes the right answer is given or asking the right question. What is the question? I don't need to have everything. I just need to have this piece, and this piece can be coupled with another piece, and that's where the collaborativeness comes in at. That's where the better algorithms will allow you to actually be more efficient and effective as you move forward. So what are we trying to do? We're trying to enable an interoperable C2 environment for joint EMS operations. There's a big push on that. And you can see all the different things that we're talking about here. It talks about strategic level all the way down to operation level, and there's a second and third order effects that gets to the tactical level. In my view, a lot of military operates in DIL environments, disadvantaged environments. It's disconnected, it's intermittent, and it's low bandwidth. How do you deal with that? How does that person at the tip end of the spear handle that situation? How do they know if someone's irradiating something? We have to be able to give them something that they can plug into and be disconnected, yet visualize what's happening around them. Here are some of the relationships. I'll let you go look through that real quick. It's hugely important. We're talking about joint C2 requirements. How do you manage the spectrum? How does the respective people or entities that want to plug in manage their spectrum? And where are the commonalities? And how do you set up a federated environment such that that enterprise architecture is applicable or could be adopted by another entity out there and allow you to layer? It doesn't necessarily always need to be federated, but to layer and have you the ability to be working in parallel and getting at whatever it is that you want to get at. From my standpoint is, operations. How do we go about taking the tools that are out there? Vice Admiral Norton talked about the ABCs. How do we go about the ABCs? Do we adopt what's already out there? And, that might give us 60, 70%, and we just, adopt that or because it's the best thing out there? Do we go out and buy something that helps us with that? Or do we create? I will tell you, we don't want to be in the creation business. Because from an industry standard, you're faster, you're willing to put the time and effort in it, and then, that makes it work for us. So we don't want to be in the create business because, quite frankly, from a military standpoint, it takes us a long time to get that through the process, especially from an acquisition standpoint. But as you look at this, you see that there's a lot of thought that's gone into this. And how do we support it? How do we define and reference those specific documents so that the joint Electromagnetic Spectrum Operations Centers which brings in our intel, which brings in our operation, which brings in our cybersecurity, which brings in even, the funding stream. How do we integrate that, inculcate that into how do we go about taking command, or rather superiority of the electromagnetic spectrum environment? And look at this here. So this is where we want to go. This is the concept. It's in draft form, but this is what we're trying to do. We want to bring all those things to bear. Talk about IT cloud, the infrastructure, and how that's going, and bring in a layer of how do you apply the electromagnetic spectrum to that. How do you then bring in, when you talk about cybersecurity, those regional boundaries, and what are the LINFACs when it comes from an electromagnetic spectrum environment? What are those coalition systems, and what are they irradiating? Are they emanating or radiating such that it can cause hurt, harm, and danger to us? You have to look at all those things and apply the very basic principles of the electromagnetic spectrum and the environmental effects that it can have on each one of those systems as you move forward. So, in conclusion, what's in your perspective? Electromagnetic spectrum is a niche community that has exploded. There's probably only a hand select of individuals, and I'm looking at one, that have an understanding of how you go about applying that. And yet, that skill set is not something that is readily taught in the schoolhouses. It's not something that is readily thought about from a commercial industry, as everyone is talking cybersecurity, and cloud and things of that nature. But as I walk around and through each one, and I've been in multiple tech nets and things of that nature, as I walk around, I'm looking for me in each one of those presentations. When I say me, I'm looking for Jack. I'm looking for Jack. So if it's not saying something about the electromagnetic spectrum, I'm like, okay, that's great. That's fantastic. But, and I don't want to be that red hat guy, but I am that guy. I'm going to look at you, and I manage chaos. That's what I do. I don't let chaos manage me. And that's been the issue. We have to make sure that as we move forward and we talk about the cloud and we talk cybersecurity and all those different things, and we talk about identity, do not be that person that becomes or supports, and hear me, you have to, what is the weakest thing in there? What are you not thinking about that could actually ruin someone's day or take your application, wherever it may be, and really you just lose it? Because that's what I do. I challenge myself, and I look at those different things. We had the conversation about the identity and all those different things, and okay, data doesn't need to, especially if you're talking about the sovereignty of data, that data doesn't have to move. If I move that data to an embassy in some other location, I'm like, well, how are you going to get it there? Well, I'm going to, we'll have the secure pipe and the secure tunnel. Well, guess what? That rides the electromagnetic spectrum. I might not know what your data is, but if I know your signature, I can disrupt that. So we have to think about how do we go about hardening that. We hardened, from electromagnetic pulse, we hardened, facilities, but we don't really harden the actual hardware. So I would like to say that if you involve, or rather you engulf your data in a shielded environment from an electromagnetic, properties, or at least shielded from being disrupted or destroyed, okay, then you're thinking in the right way. And it's hugely important. I can tell you that, well, I can't really tell you, but I can let you know that there's capabilities inherent in that has eluded a lot of folks, has eluded a lot of individuals. And you need not be a genius at this. It's some really basic principles that can be applied and used that can ruin your day. So understanding how the electromagnetic spectrum plays in part to what you do is going to be hugely important as we go forward, because everybody is emanating. Everybody has some type of signal. Your phone has a frequency assigned to it. Imagine this. If I realize what your frequency assignment is, and I can grab a little bit of information about you here, and you know, a lot of you folks go to a lot of different meetings together, right, in different locations, and I grab that information again, and I grab that information again, guess what? I just mapped you out. And from an electromagnetic spectrum standpoint, there are things that can be brought to bear. I'm not trying to scare anyone. I'm just saying that's the fact of the matter is we are beacons. We have stuff that gives beacons. So if you don't have an understanding of that, then you know you're walking around in a false sense of security. I'll leave it at that. With that said, I go back to Jack. So I identify with Jack. I hope you're starting to identify with Jack. And Jack is a great representative of how we want to be from a coalition mission partner environment, because that Jack can be in almost any presentation, that can be in almost any application, and what you don't want to be is, you don't want to be like, you don't know Jack. No Jack, I'm Jack, you're Jack. Let's be a jack of all trades in this regard from an EMS standpoint. Thank you very much. Any questions? Yeah.
I have a
Not really a question, but I think the best way to sum that up too is kind of how I think about it is like you can have all your layer 2, layer 3, layer 4 all controlled, but if you don't really think about it layer 1, that doesn't matter.
Yeah.
That's just an easy way for me to sum it up, just look at your layers. Like that's why we break it down to layers. Whether you look at DoD model or OSI model, either way, layer 1 is that spectrum. How to think of that.
You know, I'm glad you say that. You know, but it goes even deeper to that, right? Because we actually, the electromagnetic spectrum is in every layer. Every layer. You know, so how do you go about, again, the messaging about what this is and what it can do to support you and what it can do to hurt you from either a commercial standpoint or a military operational standpoint is hugely important. Yet it is something that, again, not a lot of people understand. Yes?
Yeah, and kind of following that with the military standpoint, I was Navy, right? So like the ship I was on was cruise. It had an interesting piece of radar on it that the Navy won't up until about years ago when our Navy had, which was my radar. And anytime we're in the Persian Gulf, we lit that thing off. The Iranians, the Iraqis, and all of them knew exactly what ship it was.
Absolutely.
The only ones that had it.
Absolutely. Yes, ma'am.
I had a quick question for you. In a coalition environment, when the Air Force wants to go through, we ask for permission to move through the airspace. How does it work in the spectrum environment with coalition, since the spectrum slices are different? Do we ask for permission, or do we just assume that we can operate?
Well, I would say from a manufacturer standpoint, there's a certain degree of assumption, but we do have a application that we use and we're working with the State Department where we get host nation agreement. We use what we call the HUMSWEDO, which is host nation spectrum. I can't think of the last portion of it, but we do work that. So that portion of it, we try not to assume. But again, we recognize that each nation has its own sovereignty. So if we want to come in with some capabilities, we need to make sure that that would work, especially if they give us the right frequency assignment. And if they don't, what do we have to do as part of our PACE plan, primary, alternate, contingency, and emergency plan? And it goes beyond just, again, if I come in with umpteen radios and I've assigned these frequencies, that's just the basics of it. There's the other aspects of it. How do we employ from a superiority standpoint? How do we couple with that nation to do whatever it is that we're trying to do? And there's going to be a lot of collaboration, you know. And again, because of the way in which we archaically have been going about the business of assigning frequencies, I don't need 4,000 frequencies assigned because I couldn't tell you how much of that I actually use, right? But I feel real secure in the fact that I have 4,000 frequencies. But what inevitably happens is, you know, my brother to the left, you know, is radiating at, you know, 50 degrees. I'm like, really? And he's killing me, right? But he doesn't know that he's killing me. And I'm like, okay, well, let me go to go to my alternate. But what I don't realize is my sister to the left, you know, they're doing something over there, again, what we have is blue on blue, and because we don't talk to each other, and that's another thing, communications are business, but not necessarily always a practice, you know, and then when you ask the question, you know, it disappears all of a sudden. Now, how do I know whether or not that was truly my brother or sister to my left and right, or that was someone testing my TTPs? It's hugely important. And when you get cut off from the standard communication that we you know, really depend on, and that person at the tip of the spear is out there, how do I help him or her see what's happening around them? And portion of that is, again, having some type of spectral analyzer and understanding that, you know, hey, that's an FM signal, or that's this, or that's a ballistic missile heading your way. It's hugely important. So it plays into a lot of different environments, you know, the SIG community and all those different things. So you have to understand that when you talk about spectrum management, you cannot be myopic in your focus in terms of how you employ it. You cannot be myopic in your focus in terms of all the different ins and outs that occurs with it. So it's an evolution that's occurring in this field here. It's an absolute evolution. And there are those who got some deep trenches in there that really don't get it, and I got to be honest with that, both who've been doing it for a while and those who are coming in, because we don't train it that way. So part of my job in the Joint Spectrum Center is, you know, again, we are going out and we're finding out where those gaps are at. We're doing the market analysis, meaning there's a lot of different corporations like AFRL who do these great analysis and studies, but where is that put out at? DARPA just did an excellent one, and in fact, I highly recommend that you go out on a web and you search DARPA Spectrum Collaboration Challenge 2. It's talking about, again, spectrum-dependent systems and having algorithms that are cooperating using the different frequencies that are around, and it gives about 5 different scenarios. And one of those scenarios is commercial airlines and things of that nature. Another one's a scenario where you talk about troops who are in a densely populated environment. And it speaks to the fact that there are so many dependencies on the spectrum and how it's used and how it's applied. And there are many folks who are actually going through this world and don't really get that. And because they don't get that, it's a risk when you're talking about giving something to the U.S. It's a risk when you talk about putting that out there and not understanding that those signatures, whereas technology is designed to make your life that much easier and things of that nature, it is a wicked problem set. And my job is to bring that to light and help support and bring some of this to some degree of manageability.
So it sounds like you're advocating for shielding of our devices. Is that a fair assessment?
Absolutely, to a certain degree, yes. I mean, again, if you don't know how you're emanating or what you're emanating, yet those who have been doing this continuously, they have an understanding. How do you think that they knew exactly where you were, right? Right? They've honed their craft, okay? You know, we have to make sure that, again, it's not so much a new thing, it's an old thing we learned. And what we have to be very careful of, the law of fast learning and quick forgetting. You know, we learn things really quick, we get comfortable, and we forget it. It has to be a continuous, dynamic push forward. I like to say, I like to keep it moving, you know, IT in quotes. We have to keep it moving. Thank you.
A couple of times. So why do I have to turn off my cell phone when I'm in an airplane? Is it the spectrum's too close and it's blue on blue?
Part of that is they just don't know.
Okay. Nobody's done the research to really define.
Exactly. It's, you know, again, let's think about it. If you have your cell phone on, okay, let me put this disclaimer out there. Please do not go on the telephone or on a plane and say that Colonel McCloud said it's all right to keep it on it because you guys don't know. That is not what I'm telling you to do. I'm basically saying that there's still a lot to learn about this, right? You know, so if you can be in an aircraft and they can supply you with Wi-Fi, let's think about it. If they can supply you with Wi-Fi because they're pinging on some different, you know, some satellite that's out there, how much different is that if you have your cell phone on it and it has to push down to try to get it? Is it because of separation of distance? Is it a law of, you know, tyranny in that regard? There has to be more study on it. There has to be more study on it. But again, Everybody's emanating something. Even when you're in Wi-Fi mode, or rather you're in airplane mode, guess what? You're emanating. Here's a little thing I would ask you to do. When you're on the aircraft, next time you fly out, and you're in airplane mode, and you do that, you click on, say, Wi-Fi connect, see how many people have their Wi-Fi, right? Really. We're emanating. Yep. Yep. Now let's take it to a cyber extent. Let's get a little interesting on it. Right, right. Now, from another standpoint, right? I'm sorry, I know you guys are all leaving, but this excites me a little bit because so you do keep your cell phone on, all right? Somehow, I've done something and I can get your cell phone. Now I can start piggybacking and doing a lot of other different things. It might even get, because the aircraft emanates a certain frequency as well, now I'm inside of their OODA loop. And it gets pretty scary, doesn't it? Yeah, so. Yeah. Right, right. Well, folks, I really appreciate you staying here. I hope you found it somewhat informative. I didn't want to go too deep, but again, this is a very important topic, and I appreciate you taking the time and to listen to me.